So I want to look at the loan repayment decision in Excel now using the same PVIFA formula. But how does Microsoft Excel look at calculation of annuities, that is calculation of loan repayment, right? So let me use the same example. The amounts remain the same. Amount of loan is 1,50,000. The rate of interest is, let's assume, 10% per annum, and the time period is 5 years, right. Given this and the details of the installment, which is equal installments per annum. So, we are going to repay this loan over the next 5 years, and the loan installments are going to be at the end of each year for the next 5 years, all right. Now, what is the formula for finding loan installment in Excel, right? The formula for finding loan installments in Excel is known as the PMT formula. It is known as the payment formula, PMT. So, what am I doing is, in this cell, I am going to go to the tab of formulas and say insert function, all right. And in my recently used formulas, you can see there is a formula termed as PMT. You could do a search for that as well, PMT. And if I say insert function, what it does is it opens up this dialog box which talks about filling in a few input data points, right. So, the first data that it is asking is for rate. Now, I have two options. Either I write down this manually, that is I write down 10% per annum, or I link it to a cell. It is best if I link it to a cell, and hence I do not want to type out 10%. I am going to go to my cell C4, which talks about 10% rate of interest. So, if you notice, I have not written a numerical value over here. What I have written over here is the cell C4. Then comes the next data that it is asking for, NPER, and if you read the syntax over here, it says that NPER is the total number of payments for the loan. So, NPER is nothing else but the loan tenure, right. In our case, the loan tenure is 5 years. Again, I do not want to type 5, so I am going to link a cell, and the cell for me is C5. It could be something else for you, but link your Excel sheet which has the term 5 written over there, indicating the time period of the loan as 5 years, all right. Then comes the next cell, which is PV. PV stands obviously for present value, which is the amount of loan that you are taking today, right. So, the amount of loan is nothing else but the PV, present value. Again, I am not going to type 1,50,000, I am going to go to the cell which shows 1,50,000, and in my sheet that cell is C3, all right. Then you have the cell of FV, future value. Now, obviously, the future value is blank, because once you are repaying the loan, the future value goes to 0. So, I do not need to give a value over here. Either I can type out a 0, or I will just leave it blank. I am going to leave it blank, all right. So, 5 years there, and then, you know, interestingly, Excel is asking for a term known as type. And if I read the syntax over here, and I want your attention over here, it says type is a logical value, payment at the beginning of the period type 1, and payment at the end of the period type 0, or omit the cell. Now, this is very interesting, because Excel is now going to ask you that when are you repaying your installments? Are you repaying these installments in the beginning of each year or at the end of each year? Now, the basic concepts of time value of money say that usually annuities are paid or received at the end of the time period. So, when I am paying my EMI, it is usually considered at the end of the month, at the end of the quarter, at the end of the year, and so on and so forth. Although in the market, practically when you go to a financial institution, you might choose making your repayments in the beginning of the month, in the beginning of the quarter, in the beginning of the year as well. Now, Excel specifically requires that as an input. It will ask for this cell and say, hey, what's your repayment schedule? So, if you read the installment cell over here, I have written installment equal installment per annum, but I have not said equal installment per annum means at the end of each year or in the beginning of each year. Now, standard financial models assume cash flows are received and paid at the end of each year, and that is what exactly what Excel also assumes. So, Excel also says that if you are going to omit this cell type, if I am going to omit this cell, even Excel will assume this to be at the end of each year, at the end of each month, at the end of each quarter. So, suppose if I do not write anything in this cell, Excel will take this input as 0, and 0 indicates end of the year. However, if my loan structure and the loan agreement is about repayment in the beginning of each month, in the beginning of each quarter, in the beginning of each year, then I need to give specific instructions to Excel, and I need to type 1 over here. Then my EMI calculations, installment calculations will change, right. So, all that I want to say is, if you leave out this cell blank, your installment will get calculated assuming that your repayments happen at the end of the time period. If you are going to type out 1 over here in this cell, then Excel gets the message that your installments are in the beginning of each period, right. So, I am going to write specifically over here 0, indicating that I am giving Excel this command that my installments are at the end of each year, right. That is about it. I have fulfilled all the data entry. Let me press and enter, and what do I get is 39,569 point something. If I round it off, it comes to 39,570, and that is an installment that I will have to pay per annum at the end of each year, right. So, if you also notice, these are in red fonts, and it is also an amount which comes in bracket. Now, again Excel is very intelligent. It looks at 1,50,000. If I zoom in, it looks at 1,50,000 as an inflow, and hence my loan repayments 39,570 is an outflow. A bracket shows a cash outflow. A red font shows a cash outflow. It shows a negative amount. All right. Now, so we are done with the installment calculation. If I want to now look at a loan repayment table, typically if I am going to pay 39,570 for 5 years, and if I multiply these two cells 39,570 multiplied by 5, what do I get is 1,97,848, and 1,97,000 and 1,50,000. So, let me convert this into a positive amount. 197 minus 150, what do I end up paying is a total interest of 47,848. My question is, this is an interest that I am paying across a period or over a period of time of 5 years. What is the interest that I am paying every year, right? I want to know that out of my installments that I pay 39,000, how much goes to principal, what is the amount that goes to interest, right. So, what am I doing is, I am going to create a loan repayment table over here, and this is how my table looks like. Let me color it separately. I hope this is clear. So, what is the opening balance of my loan? I am not typing out the amount. I want all cells to be linked, and hence I am going to write, I am going to link the cell C3, which indicates the amount of loan. That is the opening balance. All right. What is the installment that I am going to pay? Let me convert this installment also into a positive amount over here. So, 39,570. Installment is 39,570. Again, I am not typing out the amount. What I am doing is linking this cell, and since this installment amount is going to be the same every year, I am freezing this cell by adding a dollar sign to it, all right, and then I can copy paste it for the next 5 years. So, every year I am paying an installment of 39,570, all right. Now, the question is, in the first year when I pay an installment of 39,000, does my entire loan amount of 1,50,000 get reduced by 39,000? Obviously not, because the installment of 39,000 includes a principal amount and it includes an interest amount as well. So, I want to split my installment into principal and interest, right. So, how much is the interest, all right. So, my interest rate you know is 10% and I took a loan of 1,50,000. When am I paying this installment? At the end of year 1, and hence I use the bank's money 1.5 lakh at 10% for the entire year, which will cost me an interest of 15,000 rupees, 1.5 lakh into 10%. And hence, I am going to first calculate the interest cell 1,50,000 opening balance multiplied by, I will go to the rate of interest cell. My rate of interest cell was 10% and this cell is not going to change, right, it is going to be constant. So, I am going to lock it by a dollar sign again, alright. So, my cell C4 is locked with a dollar sign and I say enter. So, what do I get is an interest of 15,000. So, this tells me that when I paid the bank 39,000 in the first year, 15,000 rupees went towards servicing of interest, which is known as debt servicing, all right, interest servicing portion, and the balance is principal. So, out of 39,000, my cell H12, if I deduct the interest amount of 15,000, which is the cell G12, what do I get is the balance amount of principal 24,570. So, my loan amount gets reduced not by the total amount that I paid. What is the total amount that I paid to the bank? 39,000, but my loan will not fall by 39,000. My loan amount goes down only by 24,570. So, my closing balance is 1,50,000 minus 24,570. At the end of year 1, my loan in my books of accounts and in the bank's books goes down to an amount of 1,24,000, which becomes obviously the opening balance of year 2. All right. So, my year 2 balance is 1,25,430. Now, I just have to repeat this process and repeat this logic for the next balance 4 years. I am going to do that quickly and then leave it for you to find it out. I will upload the Excel sheet, let me know when do you want it, and I am happy to share this with you so that you can look at the formulas. I am going to copy paste this interest formula for the next 4 years, all right, and yeah, that is how it looks. I am also going to copy paste my principal formula and the closing balance formula. I will also copy paste my opening balance formula, and what do you notice is at the end of year 5, right, I'll just highlight that cell, all right, at the end of year 5, what you have is your loan balance going down to 0. Right, which clearly tells you that as you start repayment from 24 to 27 to 29 to 32 to 35, the principal amount is going up and the interest amount is reducing. Hence, we call this as a reducing interest balance method, right. Now, what you guys should be able to do is you should be able to prepare several such tables and be very efficient at preparing. Let us say if this was a monthly repayment, right, then you are not looking at year 1, 2, 3, 4, 5, but you are looking at month 1, 2, 3, 4, 5. Obviously, your interest calculation will change because you are then not calculating yearly interest, you are calculating interest for every month, right. Suppose this was not years but quarters, so your EMIs are every quarter, then your interest calculation will also change, right. So, here is a challenge question for you. Would you be able to, with the help of Excel, create a table which automatically expands from 5 years to let us say 60 quarters, or let us say typically a housing loan is a 20-year housing loan in India and you have monthly installments. So, 20 years multiplied by 12 months in a year, right. So, you will have 240 months. So, if you were to any point of time take a housing loan, this table will go down to 240 lines, each line representing each month, all right, and you are paying an equated monthly installment and EMI. So, with the help of if and then commands, can you create a table which automatically expands or automatically curtails itself looking at your calculation, right. So, the amount of loan changes, the amount of the rate of interest changes, the time period changes from 5 years to 20 years, and the installment is not an equal installment which is paid per annum, but per month. Maybe you could think, use your Excel skills here and say, hey, can I change the loan amount, the rate of interest, and the way the installment is paid? How do I change the PMT formula? How does my input values change in order to make this a very versatile loan repayment table, which automatically goes up from 5 years to 20 years or 240 months, and so on and so forth. So, give it a try. Thank you.